Okay, so we'll continue with the Mycin. So in Mycin, like I said, you have degree of belief in a particular rule, and or which is also called the certainty factor. So there are two things involved: the measure of belief and the measure of disbelief. So the measure of, if you take the probability of a particular hypothesis H, if the probability of that hypothesis is 1, then the measure of belief will be 1. Otherwise, the measure of belief will be given by this particular thing, which will be a value between 0 and 1 basically. But if your probability of hypothesis H is 0, then measure of disbelief will be 1, and this will be a value which will be between 0 and minus 1 basically, okay, the measure of disbelief. And if you combine the two, you will get the certainty factor. Now, if you have certainty factors and you want to combine them, okay, so say you're combining two observations that you have. So you have measure of belief using using two observations S1 and S2, right? So when you have two like this, if the measure of disbelief is 1, okay, then the measure of belief will be 0. Otherwise, you take the measure of belief of the first one, okay, HS1, and you take the measure of belief of the second one and use this equation to get the measure of belief of the both together, right? And measure of disbelief also is done in the same way. And if there are two hypotheses H1 and H2, so measure of belief of hypothesis H1 and hypothesis H2 will be the minimum of the two, and the measure of belief of H1 or H2 will be the maximum of the two basically, which logically makes sense, right? So what you find basically is that if your probability of H given the evidence E is greater than P of H, okay, then you find that the measure of belief will be greater than 0 and measure of disbelief will actually be equal to 0. And if the probability of H given E is less than or equal to P of H, then you find measure of belief is 0 and measure of disbelief will be greater than 0. So what you can observe here is that only one of them, either measure of belief or measure of disbelief, will be non-zero. The other one will be 0 basically. Okay, so looking at the expert systems, what are the advantages that we gain by using expert system? It's economical, okay, because once you write an expert system, you can make any number of copies and use it in different locations. So per user it has a lower cost. And availability, it's accessible anytime and anywhere, right? So you just have to copy it and put it into any system that you want and you can use it. So availability is much more. So the availability of an expert may be more difficult than using a program like this. And the response time, obviously we can say that compared to human beings, the response time of computers is mostly much faster or very much faster basically. And then the reliability. So you have if then rules, etc., and you are going to put the facts into it. So the deductions will be done, the deduction is done in the same way. So you find that the reliability is good because of that. And it could be greater than of the human expert also. And if you are, also using the human expert can use that information and then take their own decisions. And then you know that human beings go through things like distractions, fatigue, emotional involvement, all these things. But the program is sort of fixed, it's not going to be controlled by all these type of factors which a human expert would be going through. Then of course you have the explanation facility. So it will tell you the reasoning it went through to come up with a particular conclusion, and you can, the human expert, for example the doctor, can go through that explanation and check whether it actually is correct or not. Okay, so you can make sure that the expert system is giving the right solutions. And there is nothing like intellectual property, etc. Right? Once you have the expertise coded and kept, it can always be used, and it can be used for a very long time or permanently. Whereas human experts come and they go, right? So you have people who are employed and they leave, etc. So what happens is many of the knowledge may get lost when they leave, and you need to get somebody else who again has to get all the knowledge and then get the experience and use it. Whereas in the expert system, it's a sort of permanent repository of the knowledge. And you can use multiple experts, not necessarily one expert. So usually you will have one doctor who makes a diagnosis, but you can use 3 or 4 experts in the case of an expert system, and you can combine all the knowledge which 3 or 4 experts have and put it into the expert system. So these are all some of the advantages of using the expert system. So we can see that there is no emotion involved, just sort of summarizing what we just saw. High efficiency, so the efficiency is high compared to a human being, because a human being goes through tiredness, or they may not make the right decision. There's always a human errors, all these things, okay? And it will have the expertise in a particular domain which is put into the system, no memory limitations. Regular updates improves the performance. So you can have a knowledge engineer who actually goes and regularly updates your knowledge base and the expert system, and it will give good results. And there is no leakage of data, etc., because it's all in the form of a computer. There is no human beings that are involved, right? So the security is really high. And you have a knowledge base, and it will be considering all the information in the knowledge base. So you can say that it takes the just like in the case of Prolog, where it goes through the entire knowledge base and provides all the possible inferences from there. So it considers all the facts which are available basically. What are the limitations? Not widely used or tested. So it's not really that much in use for some reason, right? But there are a lot of expert systems which were used earlier and are not being used now, etc. And limited to relatively narrow problems, okay, and cannot deal with mixed knowledge. Okay, for example, you can have applications where you need to use knowledge from different domains which are put together, etc. So there it may not be easy to use an expert system. Possibility of error. So if there is an error in the system, there'll be an error in all the diagnoses that are made. Difficult to maintain, may have high development cost. Of course, the development cost may be high. It may also take some time to, prepare the expert system. It can also raise legal and ethical concerns, just like any AI system, right? If you have a AI system which takes some decisions and the decisions turn out to be false or not correct, who is going to take the responsibility for that, right? How do you make the AI system take the responsibility for the mistakes that it has made, right? So this type of concern is there for all AI systems. So for example, if you have um, a computer system or a computer program which is actually evaluating say exam papers and coming up with the marks of the various students and combining it together, etc. And there is some bug in that, and it's giving very erratic results which are not correct, etc. And obviously it has a lot of repercussions, because lot of students receive those marks, and their future also depends on those marks, and if there is an error, then how do you make the computer accountable for it, right? It's that is where you have legal and ethical concerns which need to be taken into account. So what are the disadvantages of it? It is like shallow knowledge. Okay, it's only whatever is there in those rules. That is what is known as shallow knowledge. Okay, so it's a very narrow knowledge, like knowledge only about that particular part of the system. Okay, so there's no deep understanding of concepts and no common sense knowledge is there basically. And other related domains, there is no information about that. It's like a closed world, only whatever is required here. Okay, and the reasoning is sort of mechanical, may not have or select the most appropriate method for a particular problem. Okay, some easy problems are computationally very expensive. Maybe, for example, it may be easy for a human expert to take some decision, but for the computer to take that decision, it may be computationally expensive, which makes it difficult. And lack of trust. If the user knows that the decision is made by the computer, he may not have the trust in that decision. So these are all different areas of application. Financial services, they make decisions about asset management, act as robo-advisors, make predictions about behavior of markets and other financial indicators. For example, the stock market, it may advise you on what stocks to buy, what stocks not to buy, etc. What are the stocks which are going to do well, etc. So this is the financial services. Mechanical engineering, where they troubleshoot complex electromechanical machinery, telecommunications, make decision about network technologies, healthcare. Healthcare we have seen, right, where they assist with medical diagnosis. Agriculture, where they forecast crop damage. Customer service, transportation, law. Okay, so all these are different application areas of expert system. So coming to specific applications, you can have something like credit granting. So the expert system takes all the information about a particular person who say wants a loan or something, and then sees whether it is wise to give credit or not. Information management and retrieval, AI and expert system embedded in products. Okay, so you have many products where you have AI, even things like the home appliances like washing machines, ACs, all these have AI embedded in them. Plant layout, hospitals and medical facilities, help desks and assistance, employee performance evaluation, loan analysis, etc. Okay, so we can see that there are a whole lot of applications of expert systems basically. So coming to expert systems, what is it that we can say about them? They are used to represent and process knowledge. So, they are basically knowledge based systems. We will also see a little later how knowledge based system, how we represent the knowledge. Okay, what we have seen till now is only predicate logic and how we use predicate logic to represent knowledge, but we will see other forms of representation which can also be used in expert system. The main components, like we said, is the knowledge base and the inference engine, and they are sort of separated from each other. So, if you take ordinary computer programs, you find that the control of the program and the knowledge base, everything is sort of mixed up. Whereas here they are separate components. You have the knowledge base separate and the inference engine separate. It's also possible that you can have a knowledge base and you can use different inference engines too on the same knowledge base, right? You can have one forward chaining system, you can have another backward chaining system, etc. And we can say that expert system would be cheaper than using actual experts, faster, more accessible and more reliable sometimes, right? But at the same time, expert system have limited knowledge, like we said, shallow knowledge. They don't have deep knowledge about why something is done, etc. Okay, that means they don't have things like common sense knowledge. Okay. And it could be difficult and expensive to develop. Okay, it's possible that it's not easy to develop such a system, especially if it has a lot of knowledge in it and if it is sort of very complex. And users may not trust them for critical decisions. Okay, so these are some of the main aspects we need to see in expert system. But one thing we can say, expert systems have been used in a whole lot of different areas and they have also worked quite well in various areas. So, it's possible nowadays with things like Prolog for us to develop our own expert system. Okay, for example, we can say you take your family tree, right, and you put into the family tree, you can put things like male Rama, female Sita. Okay, then you can say sibling Rama, Lakshmana. And have things like parent Rama, Dasaratha, and parent Lakshmana, Dasaratha. And you can have a rule which says if parent X, Y and parent Z, Y, then sibling, or you can say and, suppose we say and male X and male Z, then brother X, Y, etc. So, you can have rules like that. You can also have parent, grandparents, and you can ask questions like, is so and so the grandparent of so and so? So, it should be able to go through the rules and come up with those things. You can also have things like, is so and so the niece of this one, the nephew of so and so, the uncle, grand uncle, whatever, anything you have defined in your knowledge base, you can come up. So, what you have basically done is, when you have gone through this whole thing, all you have to do is create the knowledge base and you can put the knowledge base into Prolog, and in Prolog you can ask the questions, and the inference engine is inbuilt into Prolog. That's why it is known as an expert system shell, and you can come up with answers for that. So it's not very difficult to come up with an expert system for a particular domain if the domain is small. We'll stop at this point and continue, because expert systems has ended here, and we'll continue in the next session in the next topic.